and this is the second portion. Sorry, the other one got of our math review. For number 11, it's another percent problem, though, and it's saying if 35% natural areas to be developed, leaving 500 acres untouched or undeveloped, how many acres are to be? So this one, we could do it like we did 10, or honestly, this one might be a little bit easier set up as a ratio. If you think about it, it's saying here that 35% of an area is to be developed. 500 acres is undeveloped. How many acres are to be developed? So we're trying to figure out the developed acres. When we know 65%, because it has to add up to 100, because the definition of percent is part per whole, we know 65% is undeveloped. So undeveloped is 500 acres. So right away, I'm seeing it's jumping out at me that I can go ahead and just try a ratio on this one. So I know 65% gives us 500 acres. So how much, so 35% would give us how many acres? X acres. Okay, so I'm going to just cross multiply. There we go, that's a little bit better. I'm trying to leave some space because I know this is going to take me some long division. So first I'm going to do my long multiplication though. 535 gives me, let's see, 5 times 35, 0, 0, 5 times 5 is 25, 0, 0, 3 times 5 is 15. That gives me 0, 0, 5. That was, I'm going to read that for a second. So I should have 175. 17,500. Okay, so now I'm going to kind of bring it over here then. So basically I'm saying that 5% is equal to 175. And I'm going to go ahead and just leave my units here, but I'm going to kind of treat them as their own variables. So I'm just going to scooch them over. I have acres times percent. Just so my graders sometimes are fussy about units, and so I'm just going to leave the units on there. And then I'm going to decide, okay, and that's this times 65x. Can't leave that out right there. So now I'm going to divide both sides by 65, divide this side by 65%, of course, and look what happens to my percent signs. I already can cancel out these two units. So now I'm left with 17,500 divided by 65. Now this is why I was trying to leave some space, because here's the fun part when you get to some of the long division. Okay, so here, 65 goes into this number. Let's see, 65 has to go in 75. I would say at least twice, because 60 is 120, so I'm going to give this 130. Start with that. That's 10. 2 times 5 is 10. 2 times 6 is 12, and add that 1 is 13. So 175 minus 130 gives us 40. And I always like to, indicate where my zeros are, because it's easy for us to make a simple, easy mistake. Not going to lie, I do it all the time. 65 going into 450. Well, I know that 65 goes into 100 at least once, so I know that that's at least 4 of them. And then you add that 50 on there and residuals of at least them. And I was leaving 40, 40, 40 on the table. So I'm going to start with 6. And you may not get that number right the first time. It's okay. Just scratch it out if you don't. But 6 times, that would be 30. 6 times 6 is 36. 36 and 3 is 39. So 450 minus 390 will give us 45 minus 39 is 6. So now draw my arrow down. And 65 into 600, I did that right there too. 0 and 6, yeah. So 65 into 600, not quite, because there's a 5 on there, so it's not quite 10 times. We're going to start with 9, because we know it's going to be pretty close. Y'all can't tell, but I might use my fingers to do my 9 multiplications. But 9 5, that should give you, see what you do, by the way, you hold up and you put down your 5th finger, and that gives you 45. Okay, so 9 times 5 is 45. Y'all taught me that, by the way. 9 times 6, hold up your fingers. You hold down the 6th finger, and that gives you 54. That is the coolest trick. Oh, my goodness. So now I have 8 because I have to add that 4 to it. So 58. So minus 585 gives us, let's see, that gives us 15. And I could, but I won't, because that's, if I did telling the grader that, or basically in general, it's saying that that is an absolute number, and it's not. There's still some left over down here. So you want to make sure you add your decimal for at least one more spot. This has to do with sig figs. Okay, 65 goes into 100. We learned that earlier. It goes into 100 2 times because that's 100. Let's just do it like that. All right, so that is, and I'm left with, what am I left with up here? Acres. So I'm writing in my acres. This is my final answer. Ready for my graders? 262 acres. All right, number 12. It looks to me, concentration of mercury in water supply changes from 65 part per million to 7 part per million in a 10-year period. What is percent change? Percent change equals old minus new over old, absolute value times 100. So it goes from, wow, that's a big drop, 5 to 7. So now what do we do here? All right, you have to subtract, and so you get 67, that's 58, over 5. So now, and of course we're in times, it's going to be times 100. First, we are going to do this lovely problem where we have to actually 65 into 58. Now 65 won't go in. I'm going to add a decimal and add a 0. 65, 580. Let's see, it's almost, let's say 8 times. 8 times 5. Let's see, that's 40. And 8 times 6, that gives us 48 times 4. So plus 4, 40, 52. And I 54. Okay, so 0 here, 8 minus 2 is 6, so yeah, barely on there. Bringing down another 0, 65 goes into 600, a lot. No, it looks like it's going to be 9 times. Looks like we could squeak out because I was looking up here, my 8 gave me 520. So 9 times 5, 45. 9 times 6 is 54, 58, and 5 is 5. 15. So 0.89. And then we have to multiply that times 100. But if I do that now, it's saying that there's no residual. And let me add one more. 65 goes into 150. 2, 5 is 10, and 12, 13. Didn't we use that number in the last problem we did? So now I have to take this number, 0.892, and multiply it times 100, and I get, I'll do it over here, 89.2%. Okay, so number 13, and by the way, I think I fixed my microphone problem. I heard it was kind of staticky. So for number 13, this is an energy question. And you'll always be guaranteed to have at least one energy question. So it says a city that uses 10 billion BTUs of energy each month is using how many kilowatt hours of energy? So we want kilowatt hours on the top. So we know that BTUs, we have to use the cards up here. This one is not for this problem. Kilowatt hours, BTUs, that one is. I want kilowatt hours on top, and I want BTUs on the bottom. So over here, when I look at my first card here, 10 billion BTUs. It needs to be on top so that those can cancel. 10 times 10 to the billion is 9 BTUs of energy in 1 month. That's 10 to the 9. Is using how many kilowatt hours? 1 kilowatt hour is equal to 3,400 BTUs. The first thing I'm going to do is simplify. I always see what kind of zeros I can cancel out. I'm going to knock out those two right there, and I'm going to make that 9 now become a 7. Honestly, to make my easier, because I'm about to have to divide everything on top by everything on the bottom, so I'm about to divide 10 by 34. So I'll probably go ahead and make this 10 to the 6 and steal a 0. So let me make this 100 and this a 6. Okay, so now I'm going to have 100 times 10 to the 6, oopsie, cancel, divided by 34. And this is kilowatt hours per month. So let's go ahead and I can treat these like two separate problems. I can go ahead and I'm going to use my whole numbers over here, and I'm going to divide 4 into 100. 34 goes into 100 approximately, let's see, 3 times would probably get us over the edge a little bit too much. 2 times 4 is 8. 3 times 2 is 6. And let's see, that is 10. It becomes 9. So 32. Oof, barely. I'm going 1 0 though, because if I don't, then we're assuming that that is a exact number, and it's not an exact number. So we need at least 1 decimal place when it's not exact. 34 goes into 320, a lot. So it is really seriously a lot, but it's not going to be quite 10 because that would get us 3,400. Okay, so, 9 times 4. Use our little trick with our hands where you hold up your fingers, but I won't. So 9 times 4 is 36. 9 times 3 is 27. 7 and 3 is 30. So 320 is 306. 10 minus 6 is 4. And you bring down the 1. Okay, so we're in place, so I'm good for now. So let me look and see what I have. So now I have 100 divided by 34 is 2.9 times 10 to the 6. And if, by the way, on your math FRQ, you have to put this work in it. So you need to make sure that you're showing your work on, you're going to be doing FRQ on lined paper. But your final answer is 2.9 times 10 to the 6 kilowatt hours per month. Give them a nice circle. Circle it, and that'll make your grader. Okay, number 14. It's asking if a barrel of crude oil provides 6 million BTUs of energy, how many BTUs of energy in 1 liter? 1 liter of crude oil. Well, I know up top it gave me a card way. That 1 barrel of oil equals 150 liters. So I need that. I'm going to write that down. That 1 barrel of oil gives me 150 liters. Okay, just so I can scroll back. So I wrote it down there. Okay. There we go. Okay, so we know that 1 barrel of crude oil provides 6 billion BTUs, but how many BTUs of energy in a liter? Basically, we want BTUs per liter. So BTUs has to be on top and liters has to be on the bottom. I'm kind of in good shape over here because I coincidentally went ahead and wrote 1 barrel over 150, and that means liter, at the moment, liters is on the bottom, so that's a good thing. So we know that 1 barrel provides 6 million BTUs, and I want it to be on the bottom. So this is a card, by the way. A barrel, 6 million BTUs. I want my barrel on top, on bottom, because I want my units to be able to cancel. So here we have 1 barrel provides 6 million, which is 10 to the 6, BTUs of energy. So my barrel cancels out, and I'm now dividing 6 times 10 to the 5 over. You see what I did there? I like to simplify. I noticed that there's a 0 here, and there's a 10 to the 6 here, so I knocked out a 0, and that's why I did that. So BTUs per liter. I'm not done yet. I have to simplify that. So 15 goes into 6. Let's check it out. 15 goes into 6. Do you want to make your life a little bit easier and go ahead and get a 0 out of, let's make that a 0 and knock this back down to 4 again. That'll make your life a little bit easier. Okay, so 15 goes into 60. We know 15 times 30, so 15 times 4 is going to give us 60. So that's a nice, pretty number. That doesn't happen very often. Thank you very much, AP Central. Okay, so yeah, so your answer is 4, and I don't have to do another decimal because obviously it's 0. So 4, so my final answer over here is equal to, or you can do it over here, whatever, 4 times 10, and I'm using this 10 to the 4 BTU per liter. And I chose to do this one with exponents. You don't have to. It doesn't make you happy. If you prefer to write all this out, you could have done 6 to the 4th is the same thing as bring your decimal over. See, 1, 2, 3, 4 times. That is the same thing as you want to just keep it without exponents. That's totally fine. You can do that. For crude oil, if 150 pounds of CO2 is released per million BTUs, how much carbon dioxide is produced by each barrel of crude oil? So it wants to know how much carbon dioxide. So this has to be on top. Okay, so I know my carbon dioxide is going to be on top. So let me see what I have. 150 pounds of CO2 is released. So I'm going to go ahead and put that on. I know that 150 pounds of CO2 per million BTUs. A million is 1 times 10 to the 6 BTUs of energy. Okay, and then it says, so how am I going to figure out how much CO2 is produced? I have to figure out how many BTUs per 1 barrel. And they gave that to us in the previous problem. And they said that 1 barrel of crude oil provides 6 million BTUs. 6 times 10 to the 6 BTUs in 1 barrel. And again, I found this out from the previous problem. It says use info from previous problems. Okay, and so let's, because BTUs cancels, and I'm left with CO2 per barrel. And that's what they wanted, how much CO2 by each barrel. Okay, so I'm going to look at my zeros, and before I do anything, I'm going to see what I can knock out. Well, glory, glory. I'm knocking that out and knocking that out. So now I'm left with 1 times 1 on the bottom. So this really looks like 150 pounds CO2 6 divided by 1. So I'm just going to use a little scratch sheet over here. I'm just going to say 15 times 6 for now, and then I'll add my 0 later. But 6 is 30, and then 6 times 1 is 6, plus that 3 is 9, so 90, but don't forget I knocked it here just for simplicity. So that equals 900 pounds of CO2. So for number 16, this growth rate problem, calculate the percentage, or I'm sorry, population problem, but calculate the percentage growth rate for a country with a population of 6 million. In a year which it had 100,000, 70,000 deaths, 30,000 immigrants, and 50,000 emigrants. So we know the formula, our population growth formula, is the things that increase your population minus the things that would increase your population. So births, we had 100,000, and we had 30,000 immigrants. Minus deaths, we had 70,000 plus 50,000 immigrants. So this will give us 130 minus 70 and 50 give us, let's see, 120. And 130 minus 120 gives us just a good old 10. Okay, so 10,000 was our, but it's we need to find the percent, and a percent is basically your part per whole. So that was out of, our growth was 10,000, but of 6 million. So when we do talk about part per whole, we're saying that was the part 10,000 per the 6 million. Well, I guess I'll go ahead and do my zeros since it was already out. 1, 3, 4, 5, 6. So now all I'm going to do, sorry. I needed space, so I decided to go to the left for some reason. Okay, so knock out 0, 0, 0, knocking out another 0. So essentially, now I'm about to divide 600 into 1, and that's where I need space. So 600 goes into 0 times, right? 10, nope. And by the way, that's where the first whole number was, so I'm putting my decimal there. It goes into 0, nope. Does it go into 100? Nope. Does it go into 1,000? Yes, what, at least one time. 0.001, that gives us, what, 600, obviously. That gives us 400 left over. So let's get a 0 in on this game. And 600 goes into 4,000. Ooh, 6 times. 6 times 0, 0. 6 times 6 is 36. Okay, so now guess what? We're left with 400 again. So we know how the story's going to end. Another 0. 6 goes into this. Okay, so 6, 6, 6, 6, 6, 6. Okay, so part per whole. So when you're doing that percent, when you take part per whole, you don't forget you have to multiply it times 100. Okay, apparently it wasn't, I got cut off, so I'm going to go back and finish this. When you were doing part per whole, multiply times 100, so you move it over 1, 2, you move it to get 0.1666, but I decided to make it 0.17 because, you know, you have to round that last one.